Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So today I have came up with a very interesting problem of transportation where we need to calculate the least time instead of calculating the minimum transportation cost. So these are the cases generally encountered in the hospitals, military services and fire services, etc., where the speed of delivery and the time of supply is more important than the transportation cost. So today we are going to solve a similar problem. So let us quickly move on to the problem, and the problem says that the military equipment is to be transported from 3 origins to 4 destinations. The supply at the origins, the demand at the destinations and the time of shipment is given below. So here the supply is given from origin and the demand is given from the destinations and the time of shipment. So here this value is the time of shipment. So the only difference this matrix has from the previous problems we have solved is that the CIJ, which is the unit transportation cost, has been replaced by the time required to transport xij number of units from source I to destination j, or we can see here that time required to transport 12 units from source 1 to destination 1. So this is the time given, which is the time of shipment. So 10, 0, 20, 11, these are all time of shipment. Okay, so it says that the units to be shipped as obtained by Northwest rule are given in parenthesis. Work out a transportation plan so that the total time required for the shipment is minimum. So it has been saying that we have already obtained a basic feasible solution with the help of Northwest corner rule. So it has already been given to us the basic feasible solution, and we need to optimize this particular solution. So first of all, let us see how we can approach this type of problem. And before starting to approach the problem, we need to understand something, that this problem is different from what we have done till now. How it is different? Let us see. There the time of shipment is independent of the number of units shipped. That means the time of shipment, that means 10 is the time of shipment. So this is independent of the number of units. It does not depend on this 12. That means whether there is 1 unit, 2 unit, 12 unit, 20 unit or any number of unit, it does not affect the time of shipment. That means it will always take time 10 from source 1 to destination 1. And the second thing we need to note is that the shipments from origin to destinations can be done at the same time on the different routes. That means once we have obtained the basic feasible solution, then we do not need to add the time of individual allocations. Why we do not need to add? Because all of them can be transported at the same instant of time in different destinations. That means our transportation time will be the maximum time among these allocations. So among these allocations we can see that there are different times: 10, 0, 7, 9, 20 and 18. So among this 20 is the maximum time. So this 20 is the total time of transportation. So for this particular solution, the total time of transportation is 20, because maximum time is taken by this particular shipment and all the other shipments are having less time or are taking less time. So this means that the total transportation time here is 20, and our objective is to minimize this particular time. The total transportation time we need to minimize. So how we are going to do this? So let us see that the problem here can be solved in two parts, just as the previous problems. First is to find the basic feasible solution, which is very similar to the one we are doing in previous problems. So we can find the basic feasible solution either by northwest corner rule, by Vogel's approximation, or by least cost method. So in this particular question, it has already been given that by northwest corner rule, this solution or this basic feasible solution has been obtained. Now in order to find out the optimal solution, what we need to do here is we need to follow two steps first. The first step is that we need to make sure that if Tij is greater than equal to Tk. Okay, let us suppose. Okay, so Tij is the transportation time, okay, or I should say the shipment time from source I to destination J, and T is the total transportation time for kth matrix. Okay, so for if this is the first matrix, this will be T1. So here we can see that T1 is equals to 20 and Tij is for non-basic cell. This is for non-basic cell. So in the first part, what we will see is that if any value in the non-basic cell is either equal to our total transportation time or greater than total transportation time. If this is equal to or greater than total transportation time, then we will cross out that cell. Okay, so if the non-basic cell has the value Tij which is greater than or equal to our total transportation cost, then what we will do is we will cross out that particular cell. So this is the first part, and in the second part what we will do is that we will try to minimize this particular cell which is having the maximum shipment time. So let us start solving. So in this particular problem, first we need to see that is there any non-basic cell which is having value equal to 20 or greater than 20. So we can see here that this particular cell is a non-basic cell which is having the value equal to 20. That means what we need to do here is we need to cross out this cell. Okay, so now we have crossed out this cell. Now what we need to do is we need to try to minimize this quantity or quantities in cell, and we will try to make it 0. So how we are going to make it? So what we'll do is there are m plus n minus 1 number of allocations. Independent allocations are here. So m plus n minus 1 for this matrix is 6, and there are exactly 6 number of allocations. So if I put any value in the non-basic cell, then it will definitely form a loop. So what I will do is I will make a loop and make sure that I will able to reduce this value, and let us see what happens. So first our objective is to reduce this value. So let us form this loop. So this is the loop it is forming. Okay, so this is the loop, and our objective is to reduce this quantity in this particular cell. So what we will do is, sorry, this will not be the loop because this is not the basic cell. So this cannot be loop. Loop will be this will be loop. Okay, So what we need to do is we need to subtract some value here. So I will subtract minus theta. So theta is the maximum value that I can withdraw from here. Now in order to maintain the supply and demand, if I have done minus theta here, I have to done plus theta here. If this is plus theta, this is minus theta. If this is minus theta, this has to be plus theta. Now as we have seen that the value where we have plus theta can be increased indefinitely, so we will not look at these two values, we will look at the values or cell which is having the value minus theta. So here we can see that this is 3 minus theta, this is 5 minus theta. That means for this particular cell the value of theta is maximum up to 3, and for this particular cell the value of theta is maximum up to 5, because if we increase beyond that our values will become negative. So among these two we will select the minimum value. So what we will take here, that the value of theta is equal to 3. So we will take that the value of theta is equal to 3, and now our solution changes here. So this will be 12. This is 3 minus 3 is 0, so there will no allocation in this cell. This will be plus theta, so this will be plus 3, or I should write 3 only. Okay, so 3. This is 5 minus 3 is 2. This is 15. This is 5 plus 3 is 8. Here it is 3 minus 3 is okay 0. This is 5. So now our solution changes into this form. So again what we require is, so here this cell has already been gone out, already has been crossed out. So now I will again try to do the same thing. If I will be able to make a loop here, I will definitely make a loop, and we will try to reduce this value to 0. So let us see here, this is forming a loop again this time, and what our objective is to subtract value theta here. So if this is minus theta, this will be plus theta. If this is plus theta, this is minus theta. If this is minus theta, this is plus theta. Okay, so after allocating theta value here, this has definitely formed a loop, and what our objective is to minimize this or to make it up to 0. So let us see in this particular part also, we will see that we will ignore the cell which is having plus theta value. So we will ignore this cell, we will ignore this cell, we will only see the cell which is having minus theta value. So this is 2 minus theta, this is 12 minus theta. That means the maximum value of theta here can be 2, and the maximum value of theta here can be 12. So among these two we will put the value of theta as 12. So this one is for this, and theta equal to 2 for second iteration. This is for first iteration, this is for second iteration. Okay, now we will put the value of theta equal to 2 here, and we will see how our problem changes. So this will be 12 minus 2 is 10. This is 3 plus 2 is 5. This is 2 minus 2 is 0. Okay, 0. This is 15. 0 means no allocation. This will be 8. Okay, plus theta, that means plus 2. So 2 will be here and 5 will be here. And this has been already crossed out. Now we can see that this is another basic feasible solution we have, and according to this basic feasible solution, the value of t, which was t1 in this case, has been reduced to t2 is equals to So here the maximum shipment time is given as 18. 10, 1, 7, 9, 11 and 18. So maximum shipment time here is 18. So 18 is the maximum time here. Now once again we need to look that if any cell or if any value in the non-basic cell is either equal to or greater than equal to 18. So we can see that here 20 is greater than 18. So what we will do is we will cross out this value. We will cross out this value. Okay. So now the maximum value is 18 and we will try to minimize this or to make this 0. In order to do so, again we will try to form a loop here. So this can be seen here that this loop can be formed here. So this is the loop, and because we need to reduce this, we will start from here. This will be minus theta. So if this is minus theta, this has to be plus theta. This is plus theta, this has to be minus theta. If this is minus theta, this has to be plus theta. Now again we will focus on the cell which is having the value minus theta. So this is 5 minus theta, this is 10 minus theta. That means theta can be 5 maximum here, and here theta can maximum be 10. So among these two we will select the minimum value. That means the value of theta here can be equal to 5. So here theta equal to 5, and after putting theta equal to 5, our solution again changes and we have 10 minus 5 is 5. Here 5 plus 5 is 10. Here 5 minus 5 is 0. Here it is 15. Here it is 8, and this is 2. This is plus theta, that means plus 5. And okay, so we have total 6 allocations. Okay, and these two values are already crossed out. These two cells. Now as this has been crossed out, what let us see first that here again the value of total transportation cost changes. As we can see here that the value of transportation or shipment is 10, 1, 7, 9, 11 and 12. So among these the maximum value here is 12, and this means that our total transportation cost again changes. So this will be T3 is equals to 12. Now again what we will see is that if any of the non-basic cell is having the value greater than or equal to 12, okay, any non-basic cell which is having the value greater than or equal to Tk, that means this for this particular iteration it is 12. So we can see that 18, 16 and 14 all are greater than 12. That means we need to cross out all the three of them. So we will cross out 18, we will cross out 16 and we will cross out 14, because all of them are greater than 12. Now as we can see that the greater or the maximum transportation or shipment time is 12, and let us see if we can further reduce this. And in order to further reduce this, we need to form a loop. And as we can see here, if I move here from here to here I could not form loop. Here also if I move up to here, then I will not be able to form a loop. So if I am not able to form a loop, that means I cannot improve this solution further, and this is the optimal allocation and this is the minimum transportation time. So according to this, transportation time T minimum is coming as 12, and this value and this minimum value shows these allocations, and these are called optimal allocations to obtain the minimum transportation time. Okay, clear? So this is the last lecture of the transportation transportation model we are studying, and from the next lecture we are going to start the assignment model, and we will see how assignment model works, and also do number of examples on assignment problem. So if you like the lecture, please share the lecture. Have a nice day. Thank you.